Hello, today's video is going to be on segment addition. We're going to first start with our information. We're going to read it and draw our picture. So we're going to draw it so that point X is between Y and Z. It's important that word between. So we know X is going to be between. We've got 2 points, Y and Z. And X is going to be somewhere in between those 2 points. It is important to note that between just means somewhere. It doesn't mean that it's going to be halfway exactly in the middle. It could be closer to Y, it could be closer to Z. It's just somewhere in between those 2 points. We are given that the length of XY, so from X to Y, has a length of 8. From Y to Z has a length of 32. So if I'm starting at Y and I'm going all the way to Z over here, this entire length on the bottom is going to be 32. Our goal is to find what is the length between X and Z. So I know this small part and I know the large part. I've got to think about how am I going to get to here. To get this missing piece, segment addition tells me I'm going to add this piece plus this piece to get this. So I could say 8 plus what unknown value is going to give me to 32. To find that unknown, I move it to the other side, and my unknown segment has a length of 24. Maybe you could see right from the beginning, this is my big section. I take the big minus the little to find my unknown. Either way, you can go straight to your subtraction, or you can set up your little mini equation to find that our missing segment length is going to be 24. And that just shows us what our segment addition postulate is if I have B between A and C, so here's A, B is between A and C, segment AB plus BC, it takes those 2 smaller pieces to equal the whole AC, and that's all the segment addition postulate is. So let's go ahead and use this segment addition postulate, apply it. So example 2, I want to solve for X. I see that from A to B, this piece right here is 10. From B to C is 13. What I want to know is what is the length from A to C? I want to know the whole thing. So to get from A to C, I have to go from A to B and then B to C. So I'm going to use my segment addition postulate here that X is those 2 pieces put together. So 10 plus 13, that whole segment is going to be 23 when I add them together. Like above, so we're going to solve for X. I know from A to B, I know from A to C, I know the whole thing. I'm missing this little segment. So we could set up our equation, 37 plus X, small piece plus small piece is going to equal the whole. And then we move that 37 over. Or you could have gone directly into, I know this is the whole piece, the whole minus the small, and all you're doing is skipping 1 step there. Nope, not 73. That's minus 37. And you still get the same answer of 21. All right, we're going to make it a little bit harder now. Instead of so many numbers, we're going to introduce some more variables here. In example 4, we want to find what NO is. So we're given that from M to O, this isn't labeled. So anytime we have information that we're given that's not labeled on the diagram, the first thing that we want to do is go ahead and put that information on the diagram so that we have a better picture of what's going on. We can see our numbers a little bit easier. So I'm given that from M to O is 32. In the end, I want to find what the length of NO is. Before I can find out what the length is, I have to find out what X is. So my first step here, although my directions didn't say it, is to find out what my X value is. To do that, we're going to use our segment addition. Small piece 1 plus small piece 2. Those 2 pieces together equal the whole. So 2x plus x plus 5 is going to be equal to 32. It takes those 2 pieces, those 2 segments to equal the whole. We combine our like terms. 2x and 1x gives us 3x. Matter of solving for x, move our 5 over, do the opposite, so we subtract. 3x is equal to 27. Since we have 3 times x, to move the 3 over, we do the opposite, which is divide, and we find x is 9. Once we find x is 9, we want to find out what NO is. We take this value of x and we plug it in. So we get 9 plus 5 gives us 14. Now we can finally answer that question that the segment NO has a length of 14. And our last one for our video, still segment addition. So we want to solve for x. I'm given that the small piece RS and small piece ST, these two small pieces together equal the whole. So if I want to set up an equation, we think to ourselves, piece 1, small piece 1 plus small piece 2 equals the whole. Go ahead and push pause for 1 second and try to see if you can just do this setup. So what equation, how would you relate these pieces together? Once you write an equation down, go ahead and press play again and see if your setup was correct. All right, go ahead and check to see how you did. Piece 1, small piece 1 plus small piece 2, those two segments together have to be added in order to get the whole segment RT. We combine our like terms. 3 and 4 gives us 7x. Now the next step, there is no wrong way to go, but when you're trying to solve and you have x on both sides, look to see which one's smaller. I move the smaller one to keep my x positive. So 7 minus 6 gives me x minus 1 equals 13. Add that 1 over, always doing that opposite operation, and we find that our x is going to be equal to 14. All right, and now we are all done for our video on segment addition.